Hello everyone. Today we'll be solving Cambridge IGCSE Chemistry Paper 2 Multiple Choice, May-June 2022, May-June 2020, Variant 2-2. Guys, in this question paper, in this video today, we'll be solving from question number 1 to question number 20. Guys, at the time of recording this particular video, our channel had 248 members. Question number 1. A mixture of ice and water is left to stand and the ice melts. Which row describes what happens as the ice is melting? So, temperature of the mixture. Since the ice is melting and it is still with that particular water, alright, ice and water is in that mixture, the ice will keep the solution at a temperature of 0 degrees Celsius. So, temperature of the mixture will not increase as the ice is melting. It will stay the same. However, the energy changes. Average kinetic energy of the particle increases. Now, average kinetic energy of the particles will not increase because the temperature remains the same. All right, the heat energy that we are providing from the surrounding will be used, all right, to overcome the attractive forces in the ice. So, temperature of the mixture will stay the same, and energy then the energy that is gained will be used to overcome the attractive forces. So 1D will be the correct answer. Guys, moving to question number 2. Which piece of apparatus is used to measure 25 cm cube of aqueous sodium hydroxide? Okay, so if we want to measure accurately 25 cm cube of aqueous sodium hydroxide, we can use a pipette. A pipette can be the best way of measuring it because pipettes are good at measuring fixed volumes of 25 or, like, for example, 10 or like 50 cm cubes very accurately. So A, pipette, B, conical flask, or C, measuring cylinder, C, a beaker. None of them will be correct. Question number 3. Paper chromatography is used to determine the RF values for 4 different food colorings. Which food coloring has an RF value of 0.6? So food coloring, those that had an RF value of 0.6, we'll have to find out. Okay. For finding out RF value, what we can do is we can measure the distance from the baseline until the solvent front. So which is given as 25. All right. And then we'll have to measure the distance from the baseline to the middle of the solute. All right. So RF for C equals to 15 divided by 25. All right, equals to, we can see 15 divided by 25 is equals to 0.6. So C will be the correct answer. Guys, question number 4. The diagram shows the electronic structure of a particle with a nucleon number, mass number of 40. All right, so it has a nuclear number or a mass number of 40. Now the question says the table shows the suggestions that the 3 students 1, 2, 3 made to identify the particle. All right, particle. The student 1, argon, 2, chlorine, and calcium. Student 3 said calcium. Which students are correct? Okay. Now for mass of 40, if we look into the periodic table, for the mass of 40, we know that argon has 18 protons. However, its nucleon number is 40. Calcium, alright, has 20 protons and 20 neutrons. So its mass is also 40. So 1 and 3 will be the correct answer. Guys, for this particular question, the use of the periodic table is a must. Moving to question number 5. The electronic structures of 2 atoms P and Q are shown. Okay, so we can see the P and we can see the Q. In the P, we can see that it has 7 electrons in the outer shell, so it is missing 1 electron. So it is in, naturally this is in group 7. And for Q, this is in group 1 because there is only one electron in the outer shell. Okay. Now P and Q combine together to form a compound. What is the type of bonding in the compound and what is the formula of the compound? Good. The type of bonding in this particular compound, the P and Q, because P belongs to group 7, so it will require one electron. So it will take in one electron, and Q, which has one electron in the outer shell, will give one electron. So the type of bonding will be ionic. The bonding will be ionic between P and Q. And since they will be taking one electron and giving one electron, so the formula of the compound will be PQ. So A will be the correct answer. Question number 5A. Question 6. Which statement about the structure of a metal explains why metals are malleable? So guys, the reason why metals are malleable, it's because they have delocalized electrons. They have ions, those that are in a regular structure. So when you hammer that metal, the delocalized electron can actually displace its position to best suit the attraction between the positive metal ion and the delocalized electron. So that's why they are easily malleable. So let's see, the electrons can move freely throughout the lattice. All right, now the movement of electron only explains why it can conduct electricity. So A is wrong. The layer of metal ions can slide over each other. Yes, exactly. So the layer of metal ions can slide over each other, which is the main reason why metals are malleable. The layers can slide over each other without breaking. The delocalized electron has a very important part to play in it. However, it is the metal ion that can slide past each other, which is why they are malleable. Now the next part C, the metal ions are positively charged. Being positively charged would explain why it is brittle. It wouldn't explain why it is malleable. So definitely that will not be the correct answer. There is a strong force of attraction between the metal ions and the electrons. The strong force of attraction between the metal ions and electrons can increase melting point, can increase boiling point. However, it won't increase, it won't give the metal the ability to become malleable. So B is the only correct answer. Question number 7. The bonding structure and melting point of sodium chloride and sulfur dichloride are shown. Compound: sodium chloride, bonding ionic, structure giant lattice, melting point 801 degrees Celsius. Sulfur dichloride, covalent bonding, simple molecular structure, and minus 121 degrees Celsius is the melting point. Why does sulfur dichloride have a lower melting point than sodium chloride? Alright, so the covalent bonds in sulfur dichloride are weaker than the attractive forces between molecules in sodium chloride. Now, questions that is related to covalent bond and question related to attractive forces between one sodium chloride and another sodium chloride. That is a little bit illogical in a sense that covalent bonds formed by sharing of electron and sodium chloride formed bonding due to giving and taking electron. So this does not help us to explain why sulfur dichloride has a lower melting point. Melting point can be explained by intermolecular forces, and covalent bond is not intermolecular forces, guys. So moving on, part B. Okay, the covalent bond in sulfur dichloride are weaker. So we already talked about that the covalent bond has nothing to do with intermolecular forces. We'll have to talk about intermolecular forces in order to explain melting point. The attractive forces between molecules in sulfur dichloride are weaker. Okay, this is a correct statement. Then the attractive forces between the molecules in sodium chloride. Now in part C, the problem is sodium chloride does not have molecules. It has ions, not molecules. The attractive forces between molecules in sulfur dichloride are weaker than the ionic bonds in sodium chloride. This is a correct statement. Sodium chloride has ionic bonds and sulfur dichloride are molecules, those that attract each other. So molecular attraction is less, that's why the melting point is lower. Part 8. Lead 2 nitrate reacts with potassium iodide to form a yellow precipitate PbI2 and are soluble salt. potassium nitrate. What is the equation for the reaction? Now, lead nitrate can react with potassium iodide to produce PbI2. Guys, this reaction is wrong because there is 2 iodine that is needed and only 1 iodine to be supplied. So this is wrong equation. Alright, the next equation, lead nitrate reacting with 2 potassium iodide producing PbI2 plus KNO3. Guys, in this equation there were 2 nitrate and we can see 1 nitrate on the right hand side, so wrong. Then third equation, 2PbNO3 to 2KIPBI2 and 2KNO3. Guys, here the problem is there is 2 lead in the left hand side and 1 lead on the right hand side. So that is also wrong. So definitely D will be the correct answer. Let's see why this is correct. PbNO3 2 reacting with 2KIPBI2 and 2KNO3. Guys, if we try to match, there are 2 potassium on the right, 2 potassium on the left. There are 2 iodines in the left, there are 2 iodines on the right. There is 1 lead, there is 1 lead, there is 2 nitrates, and there is 2 nitrate. So yes, this is a balanced equation. 8D is the correct answer. Question number 9. The Haber process is a reversible reaction. N2 gas reacts with H2 gas to produce 2 ammonia gas. A reaction has 30% yield of ammonia. Which volume of ammonia measured at room temperature and pressure is obtained by reacting 0.75 moles of hydrogen with excess nitrogen? Guys, when questions like these are given, remember it is the hydrogen which is the limiting reagent. So we'll have to mention 0.75 over here. Now, if we look into the ratio of the reaction, 1:3:2 moles ratio we can see. So whatever the number of moles of hydrogen, alright, will be divided by 3 and multiplied by 2 to find out the number of moles of ammonia. Alright, because it is a 3:2 ratio. So 3 basically 0.75 divided by 3, alright, divided by 3 so that we get the ratio for 1 mole, and then multiplied by 2 so it gives 0.50. So the amount of ammonia that we were technically supposed to get with excess amount of nitrogen was 0.5 mole. However, the reaction has only a 30% yield, so multiplied by 30%. When 0.5 is multiplied by 30%, 0.5 into 30%, the answer comes 0.15. Now 0.15 moles. Then obviously 0.15 moles we have to convert it into cm cube to get the original value. So multiplied by 24,000. Guys, we're multiplying it with 24,000 to get the volume. Alright, we're using the formula volume is equals to number of moles multiplied by 24,000. Alright, in the gas formula. Alright, so 0.15 multiplied by 24,000 gives us 3,600. So A is the correct answer, guys. 9A is the correct answer. Guys, moving on, question number 10. Electrolytes can be broken down by electrolysis. Okay, good question. Which rows are correct for each electrolyte? Guys, many of you will find this particular question extremely difficult. Alright, let's see how this question can be made as easy as possible. I would definitely suggest that memorizing a little bit of few common compounds when they are electrolyzed will definitely take you a long way in answering this kind of question. Dilute aqueous sodium chloride. So when talking about dilute aqueous sodium chloride, guys, in dilute sodium chloride we have Na plus, we have Cl minus, we have H plus, and we have OH minus. Since this is dilute, alright, in terms of anion, hydroxide will be the one that will go towards the anode. In terms of cation, hydrogen ion due to the reactivity series will go towards the cathode. So the reaction at the cathode will be 2H plus 2 electron H2, correct, and product at anode, hydroxide gives us oxygen, guys. Alright, at the anode, so oxygen will be produced. Number 1 is correct. Alright, if number 1 is correct, however, 2 C and D will definitely be wrong. Alright, let's see. Concentrated hydrochloric acid. Guys, in concentrated hydrochloric acid, guys, When we see concentrated hydrochloric acid, let's see the ions that are present in concentrated hydrochloric acid are H plus, Cl minus, H plus from water, and OH minus. So as we can see, cations is only H and H plus ion, and since it is concentrated, so chloride will be favored. So 2H plus 2 electron H2 in the cathode reaction correct, and product at anode will be chlorine, also correct. So 1 and 2 correct, so A will be correct. Guys, let's see why 3 and 4 is wrong. Molten aluminium oxide, the ions that are present here are Al3 plus and O2 minus. However, as you can see, oxide which turns into oxygen and gives off 4 electrons. This is definitely not going to go towards the cathode. The cathode is negative, oxide is also negative, so it will never go towards the cathode. Now the next thing is concentrated aqueous sodium bromide. Guys, in this one, so aqueous sodium bromide, meaning that there is Na plus ion present, there is Br minus ion present, there is H plus ion present, and there is OH minus ion present. So keeping that in mind, so concentrated aqueous bromide, all right. So we can definitely see here, since it is concentrated, all right, we will get bromide in the anode. However, in the cathode we will get hydrogen. So the equation says that in the cathode we are getting sodium, which is a wrong equation. Definitely we'll get hydrogen in aqueous electrolysis. There will be competition between sodium and hydrogen will definitely win the race. So question number 10, A is the correct answer, guys. Question number 11, the electrolysis of aqueous copper to sulfate using inert electrodes is shown. Okay, aqueous copper to sulfate, we are using inert electrodes. Which statement about the reaction at an electrode is correct? Guys, in this kind of electrolysis, we know that the aqueous copper to sulfate has ion Cu2 plus, there is sulfate, there is hydrogen ion, and there is hydroxide ion. Guys, when it comes to competition between sulfate and hydroxide, we always know hydroxide is going to go towards the anode. So this is the one that is we're going to find in the anode. And between copper and hydrogen, copper is lower in the reactivity series, so copper is going to go towards the cathode. Now the solutions blue color comes from the Cu2 plus ion. As the Cu2 plus ion in the cathode will gain electron and turn into copper, so the Cu2 plus will gain 2 electron and turn into copper. So definitely what's going to happen is that the copper's blue color will slowly fade away. This is blue, and once the blue, once the copper ion is gone, the blue will fade away. Now we see copper ion gains electron at the negative electrode. All right, which statement about a reaction at an electrode is correct? Yes, copper ion does gain electron at the negative electrode. It is correct. Let's move on. Copper ions gain electron at the positive electrode? No. Copper is positive. It will never go towards positive electrode. Hydrogen ions gains electron. Guys, we already know copper is in the lower of the reactivity series. Hydrogen ion cannot gain electron. So A will be the correct answer, 11. Guys, moving on to question number 12. Methane burns in excess oxygen. The equation is shown. Methane plus oxygen, carbon dioxide, and water. Bond energies are shown. What is the bond energy change for the reaction? Okay, this is a little bit of critical question, guys. We will definitely have to find out what bonds that they have. So in a methane there are 4 CH bond. In a oxygen there is OO double bond. All right. In carbon dioxide there is CO double bond, and there is 2 water, and each oxygen is bonded with 2 hydrogen in single water. So if we do the bond energies, guys, the methane CH bond that is being broken down will be 410 multiplied by 4, because there are 4 of them, as you can see. All right, there are 4 of them, which will then be added to break down bond energy of 2 oxygen, which will be plus 2 into 496. All right, then the CO double bond, there will be 2 into 805, plus there will be 4 into OH. Each OH is 460. All right, so 410 into 4 plus 2 into 496 minus 2 into 805 plus 4 into 460. All right, that will be our answer. So we can see definitely A matches our answer to find out the reaction. energy change. So A will be the correct answer, guys. Question number 12, A. Question number 13. Which statement about hydrogen fuel cells are correct? Water is formed as the only waste product. Okay, so hydrogen fuel cell does produce water. All right, that is correct. Number one, correct. If number one is correct, then C and D is already wrong. So let's see. What about number two? Point number two. Both water and carbon dioxide are formed as waste product. We know that hydrogen fuel cell does not produce carbon dioxide. All right. Then point number three. The overall reaction is 2H2O plus O2 producing 2 water. So definitely that is a correct equation, overall equation for hydrogen and oxygen's reaction. The overall reaction is endothermic. No, the reaction is exothermic, releases a lot of heat energy. 1 and 3 correct. Question number 13, A is the correct answer. Guys, question number 14. Which list contains only chemical changes? All right. Now we know that melting is a physical change. All right. So freezing is a physical change. All right, neutralization, polymerization, combustion, these are all chemical changes. Boiling is a physical change. So 14C will be the correct answer, guys. Question number 15. The results of adding excess marble chips calcium carbonate to hydrochloric acid at 50 degrees Celsius and 30 degrees Celsius are shown. Only the temperature is changed. All right, so which row describes the reacting particles at 30 degrees Celsius compared to those at 50 degrees Celsius? So at 30 degrees Celsius, definitely the reacting particles collision rate is much lower, and the collision energy is also much lower. So definitely 15D will be the correct answer. At lower temperature, collision energy will be lower and collision rate will be lower. Guys, question number 16. Methane reacts with steam with an equilibrium an equilibrium is reached. So when methane is reacting with steam, it produces carbon monoxide and hydrogen. The forward reaction is endothermic. Which row shows how the amount of hydrogen at equilibrium changes when the pressure or the temperature is changed as indicated? All right, change in temperature. All right, so the reaction is endothermic. All right, even though the reaction is endothermic, okay, so endothermic reaction, what it does is that it absorbs heat energy from the surrounding. All right, and change in temperature, which row shows how the amount of hydrogen when the pressure or the temperature is changed as indicated. Okay, so change in temperature, there will be no change in temperature. All right, a change in pressure. All right, because there are 4 moles of product. All right, and when hydrogen is formed, then the change in pressure will increase. All right, and the amount of hydrogen, all right, because of the increase in pressure will decrease. Question number 16. When aqueous iron 3 chloride is added to aqueous potassium iodide to a chemical reaction occurs and iodine is formed, which statement is correct? Iodide ions are oxidized, they gain electrons in this reaction. Okay, if we see right, in the reaction iron 3 chloride and potassium iodide, a chemical reaction occurs, iodine is formed. All right, so iodide forming iodine must lose electron. The question point 17a, it says that iodide ions are oxidized, they gain electron. Oxidation is not gain of electron, oxidation is loss of electron. The iodide ions are oxidized, they lose electron in this reaction, and this is the correct statement. So B is the correct answer. Let's see point C and D. Iron 3 chloride is oxidized in this reaction. No. Neither iodide ions or iron 3 chloride is oxidized in this reaction. This is also a wrong statement. So B is the correct one. Question number 18. The graph shows how the pH of a solution changes as an acid is added to an alkali. So when an acid is added to an alkali, it produces salt and water. Which letter represents the area of the graph where both acid and salts are present? So acid and salts are present will be present in portion D, because after pH 7, as you can see, after pH 7, extra addition of acid will cause the solution to become acidic. and the salt that we have already produced during the neutralization process will also be present. So D will be the correct answer. Which statement describes a weak acid? A weak acid partially dissociates. So whatever it says, an acid is not a proton acceptor, by the way. An acid is a proton donor, and it is fully ionized in aqueous solution. So 19C is the correct. All right. Since it says it's a weak acid, so it must be partially ionized. 19D is the correct answer. Question number 20. The apparatus shown is used to prepare aqueous copper to sulfate. Stirrer, heat, solid X, filter X, excess solid of X, aqueous copper to sulfate we can get. What are X and Y? So X, okay. X cannot be copper. The reason why X cannot be copper because it is not going to react with dilute, X cannot be copper because copper wouldn't react with aqueous iron to sulfate. Copper is a less reactive metal, so will not be able to displace iron to sulfate. All right. Part B, copper to chloride and disulfuric acid won't react together, so B will not be correct. Copper to oxide and disulfuric acid will react together to produce copper sulfate. So this will be the correct statement. Question number 20, C is the correct answer. Guys, that's all for today's video. Thank you for watching. All right, if you like videos like this, then definitely subscribe to our channel. At the time when you were watching this particular video, our channel had 248 members. So I would like to say that that's like 248 members family. All right, definitely guys, if you have any questions, definitely write me in the comment. I will definitely try and resolve the particular answer for you. All right, and keep watching the videos. That helps. All right, bye. See you in the next video, guys.